Hello everyone, our names are Ali Alcald and Ali Mullah, and we are Group 15. Today, as part of our quality assurance and testing course assignment, we're thrilled to present a widely adopted automation testing tool in the industry called JUnit. JUnit is a very popular tool for performing white box testing in Java-based applications, as it mainly helps defining and executing unit tests, which, in other words, means that it supports the stage of test execution. As it ensures the correctness of the business logic of the application, accessing the codebase is necessary in order to use it. In addition, JUnit provides reports on the outcomes after executing the tests. This makes life easier for the developer when they need to analyze and identify the unexpected behavior in their code. JUnit is strongly linked to structural testing as it is a tool that helps developers perform white box testing and thus test the code base, based on different types of code coverage, which we highlighted in Lecture 9, Code Coverage. JUnit is an open-source testing tool, which means that it allows everyone access to its source code. The development of JUnit has involved collaboration from the developer community and other contributors. It is maintained by the developers in the core team, but also from many other contributors that constantly suggest new solutions for adding new features or fixing existing bugs via, for example, pull requests on GitHub. Now, we will show you our demo using Junit5. The system under test that we have chosen for our demo is a model for graph representation that we have developed ourselves. This includes creating a graph, adding or deleting a node or edge to or from the graph, and getting general information of the graph structure such as the neighbors of a certain node or the size of the graph. This model can be used as a basis for software systems such as flight or public transportation networks. Although our system under test is relatively small, it is enough for us to introduce various features of JUnit. Here we have our test suite to test our graph model, where we have used various features in Junit5 to configure, execute and reuse our test cases. To configure our entire test suite, we use the before all annotation to prepare any important operations such as establishing a connection with the database, but in our case, we only create an instance of our graph model and insert to it a number of nodes and edges randomly. This setup method will be run once before all test methods in this test class, unlike afterall, which is run once after all test methods for cleanup. In certain scenarios, tests may require a specific execution order, despite that a good test suite should have independent test cases runnable in any order. To achieve this, we used order annotation ensuring this method runs first. Here, graph properties are tested using assertAll, which contains multiple related assert statements. If one fails, the entire method fails, however, the others continue, enabling the reuse of a method for varied test cases while identifying failed ones. Another interesting feature in JUnit is to set a time constraint on a test case with timeout annotation, which causes the test method to fail if it exceeds that time. This can be good to use to test the performance of an algorithm with high time complexity. To reduce the number of test methods and reuse code, Junit5 has a valuable feature that enables writing a single test method that can be used for several test cases where only the input parameters differ. These input parameters can be generated in several different ways. Here for example we use @ValueSource as we only have one parameter. These 4 inputs represent 4 test cases. CSVSource works the same as ValueSource but is used for test methods with multiple parameters, like this test method where each input pair represents a test case. But if these parameters are more complex, we can instead use MethodSource where we can use a separate method, like this one, to return the values of these input parameters. Moreover, JUnit offers more advanced test configuration, such as environment-specific or operating system configuration where certain test cases are executed only if a certain condition is met. This might be useful in several real-world scenarios, for example if a test case requires access to a database that is only available on the production environment, or if this test case tests a feature related to a specific operating system. For example, These two test cases are ignored since one of them is only executed on the production server, and the other one is not enabled on Windows, as you can see on the Run window. One more feature that is new in Junit5 is ensuring that a method actually throws an expected exception using assertThrows function, as we do here. This test case will pass only if removeEdge method throws this specific exception type. In other words, other exception types will make this test case fail. Based on our experience, it has been flexible to use JUnit, where the setup also felt smooth as we used Maven. Regarding the strength of JUnit, there are, to begin with, various assertions in JUnit that can fit different scenarios and several data types, which makes it easy to write a test method based on the context. In addition, it is heavily dependent on annotations, which makes it flexible to use and configure different features by only adding a certain annotation without writing any additional setup code for these features. As a weakness, JUnit has no support for property-based testing, as it has no built-in functions to generate input data sets randomly. Something else that could be improved with JUnit is to provide support for one or several types of code coverage, without integrating with other tools to achieve that. We have gained practical experience in defining and executing a test suite containing differently written and configured test cases with their inputs and expected outcomes. Additionally, we have learned to execute parameterized tests efficiently to cover different test cases associated with the same method, by writing less test methods. For takeaways, use Maven to configure. Use annotations and assertions for smoother execution. Integrate with other tools to cover all test stages. Read about parameterized test and JUnit5 documentation before get started.